All right, so remember in here we're talking about one-to-one functions and inverses. In this case though, we are talking about a function to begin with. What's the definition of a function? What's the definition of a function? A relation in which for each x coordinate there is only one y coordinate. We had that in test number 2. All right, and remember, if the graph was given, did you use the vertical line test to determine if the graph represented a function? So for each x coordinate, there's only one y coordinate. So I'm going to draw some functions here, something like this. That quadratic function we just talked about. We talked about lines before. We talked about ordered pairs. All right, so all these that I've drawn are functions. They're all functions. These pass the vertical line test, and this right here, for each x coordinate, there's only what? One y coordinate. Same thing here. If I have 6, 1, 2, 3, -1, 5, 3, 1, that's still a function, right? And the last one I just did, is that a function? Yes. Even though the y value occurs more than once,
You don't have to. There's only one for each x.
there's only one for each x. So for each x coordinate, there's just one y coordinate. And it's okay for the same y coordinate to represent 2 x coordinates. But not all of them have inverses. So we want to talk about one-to-one function and inverse functions. One-to-one functions and inverse functions. So all these are functions, but not all of them have an inverse. Right? Well, in order for a function to have an inverse, in order for a function to have an inverse, in order for a function to have an inverse, the function must be a 1-to-1 function. A function must be a 1-to-1 function. So that's something totally new to you. You probably never heard that word before, a 1-to-1 function. Sometimes I will abbreviate 1-to-1 like this, just to let you know if you see it. 1-1, mean 1-to-1. Okay, 1-1. Okay, well, what is a 1-to-1 function? Okay, well, remember what a function is. What's a function? A relation in which, for each x coordinate, there's only one y coordinate. And we want to eventually talk about inverse functions. Well, an inverse function undoes what the function does, what the original function did. So an inverse function an inverse function undoes what the original function did. So for example, the easiest function to talk about with regards to inverses is a linear function. So listen carefully. Suppose you're told that f of x is 3x minus 8. 3x minus 8. Now listen to the words. The two operations that this function f of x does is, if I take a value for x, what does that function do to that x? It does what first? Multiplies it by 3, so multiplication, and then what? Subtracts 8. Is that an 8? Yes. So the two operations that involved here are multiplication and what? Subtraction. Let me make, I don't want some of you to think this means substitution, so I'm going to write the word subtraction. So subtraction. So if this function multiplies the value of x by 3 and then subtracts 8, then the inverse operation has to, the inverse function, I'm going to rephrase that, inverse function, the inverse function has to undo it. So what operations will be involved there? Division and addition. Good. So the inverse function of f of x will undo those operations. So the operations that it will impose are division and addition. All right, so I'm just going to do a t-table right now. I'm going to come back to it if we have time. If not, we'll come back to it tomorrow. But let's look at this t-table for f of x. If x is 0, then when I plug in the value of 0 for x, I'm going to multiply by 3. So 3 times 0 is 0. Then we subtract 8, I get what? If x is 2, 3 times 2 is 6. 6 subtract 8 is negative 2. If x is, let's say, negative 1, 3 times negative 1 is, and negative 3 and negative 8 is negative 11? Okay. So this function takes x and gives me this y, right? Listen to the words. This function takes the x value and it gives me an output, this y output, correct? The inverse function takes negative 8 and brings it back to what? 0. That's what the inverse function does. It takes these y values and it brings them back to the x value. Okay? You're going to see this. It's very easy to see once we get into it. But keep in mind that that's what an inverse function does. It undoes what the original function did. Okay? Now, in order, though, for us to talk about an inverse function, this function has to be what kind of function? 1-to-1. So let's talk about a 1-to-1 function. What is a 1-to-1 function? Well, remember, we're talking about functions and inverses, right? So the inverse undoes what a function did. And remember, a function, the definition says for each x coordinate, there's got to be what? One y coordinate. So think inverse. Remember a while ago I said it takes -8 and brings it back to what? 0. It takes -2, brings it back to 2. It takes -11, brings it back to -1. So if a function for each x coordinate, there is only one y coordinate. For each x coordinate is only one y coordinate. Then a one-to-one function says what? For each y coordinate, there is only one x coordinate. So it does. So think going the other way. So a one-to-one function says this. For each y coordinate, there is only one x coordinate. For each y coordinate, there's only one x coordinate. Okay? So let me ask you this. At the beginning of class, we graphed quadratic functions. Right? If you can go back and look at them, are those quadratic functions one-to-one functions? No? Anyone say yes? Say no, okay. Well, let's go back and look at these graphs. So let's go back and look at a couple of the graphs that we did. So remember, a one-to-one function says that for each y coordinate, there's got to be what? 1x. All right, guys, look. You tell me when y is 5. When y is 5, this was 5 what? I'm sorry, this was, 5, 5. And this was -1, 5. When y is 5, do I get just one x coordinate? No. I get how many x coordinates? 2. So is this a one-to-one function? No. In fact, in the test number 2, when you were asked, is this relation a function, you use what test?
The
Vertical line test. When talking about a one-to-one function, if the graph is there, what test do you think you can use for that one?
Horizontal line test.
Horizontal line test. Very good. So if I go back to what we did earlier, this thing that I drew. So is this function one-to-one?
Nope.
No, because no matter where I draw the horizontal line, at least one horizontal line crosses the graph how many times? Twice. Again, what that means is this. For this y value, see these y values are the same, right? How many x values are there? 2. So this fails the horizontal line test. So this is not one-to-one function. So I'm going to go back here. Let me just do it here. Fails the horizontal line test. So it's not what? One-to-one. Since it's not one-to-one, will it have an inverse?
Nope.
No. So these quadratic functions don't have an inverse. Okay? All right, well, what about a linear function? Is it one-to-one function?
Yes.
Who said no? Brian, why do you say no?
It's a line.
Still like quadratic, but it might not be the same.
Well, quadratic and a linear don't have the same graph.
I know, I was just thinking of the line, really fast lines.
That's linear graph, right? Is it one-to-one?
Yes.
Yes. It passes the horizontal line test. No matter where I draw that horizontal line, it crosses the graph how many times? Once.
So x equals 0, it would only cross it one time.
What do you mean by x equals 0?
If we just have a horizontal line.
Where? Where are you talking about?
He's talking about an actual horizontal line.
Oh, I see. All right. So good question. All right, good question. So he's asking this, and he really stated it wrong, by the way. He was asking about a linear equation with slope 0. You had that in your test too. What kind of line has slope 0? Horizontal. He was asking about horizontal, although he named it wrong. He said x equals 0. A horizontal line is named what? Y equals 0. Y equals 0. Let's look at that. This is y equals 0 right here. Is that 1-to-1? No. Because remember, 1-to-1 function says that for each y coordinate, there's got to be what? Just one x. You got an infinite number here. When y is negative, when y, remember all these are what? What your y coordinates are what here? 0. When y is 0, what's this x coordinate? When y is 0, what's this x coordinate? So there's an infinite number. So it fails a horizontal line test. So it's the only linear function that is not 1-to-1. A horizontal line. Yes.
Now, we have a problem that doesn't open up or down, it opens from the side.
Okay, very good question. Very good question. And I'm glad she brought that up, because if you watch one of those 3 videos, it discusses that. But she's asking this. She's asking, well, what if you had a relation? What if you had a relation that did this? Okay? And so she's thinking, well, that passes the horizontal line test, right? Well, there's a flaw there. First of all, when we talk about 1-to-1 function, it better first of all be a what?
Function.
Function.
So it has
That's
to
not a
pass
function,
both.
it fails a
It has to pass
vertical
vertical
line.
and horizontal line
Does that
test.
answer your question? So that's not a function to begin with, so we can't even talk about it. A 1-to-1 function has to first of all be a what? Function. And then, once the function, then you determine whether it's 1-to-1. If it's 1-to-1, then it will have an inverse. Okay? All right, but that's a good question. All your questions are good, by the way. I'm not singling her out. All right, let's look at this. Let's go back. Let's go back and look at that. If I can find it. Okay, let's go back over here. This right here. All right. So we now know that this function, f of x equals 3x minus 8, is that a 1-to-1 function or not? Is that a 1-to-1 function? Yes. Because what kind of function does it begin with? Linear. All linear functions are 1-to-1 except which one? Horizontal line. What's the slope of that line right here? 3. It's not 0. And in fact, if you look at the t-table that I drew for it, when x is negative, when y is -8, how many y values did I get? Just 1. When y is -2, how many y values did I get? Just 1. When y is -11, how many y values did you get? Just 1. If you kept on going, you would see that would be the case. But all you had to do is recognize that this is linear. I was hoping that at this point you would know what a linear function looks like. So this is a linear function. all linear functions are one-to-one except the horizontal lines. So that will have an inverse. All right? Now, we said that the inverse undoes what the function did, right? All right, let me tell you about notation. Okay, so listen carefully. Notation for inverse. All right, so if my original function is f of x, the inverse is written as, now listen carefully. I'm going to write it out, and then we're going to talk about some things that may confuse you. All right, write this. See that -1? It looks like it's an exponent, right?
Sure does.
But it's not. So don't think of this as being f to the -1 power. That's not what that is. Don't confuse that. Don't confuse that notation with something we talked about the other day. We had 5 to the -2nd power. 5 to -2nd power, that base 5, if I want to make that -2 positive, I would write 5 as what? 1 over 5. So 5 to -2nd power means 1 over 5 squared. That is an exponent. But these are functions here. So in terms of function notation, if you see that -1 in the exponent, that's not an exponent, by the way. That's not 5 to -1 power. What this reads as is this. This is read as f inverse of x. That's how you read it. So f inverse of x. You understand that's not an exponent, right? So if you're dealing with the functions and you see that -1 is an exponent, that's not an exponent. That's just notation. That's read f inverse. Just like this would read what? G inverse of x. Okay? All right, now, let's go back to f of x here. You have enough information from our discussion to kind of tell me what the inverse of x, what the inverse of f is. Okay, listen, okay, we can do this together, and then I'll give you one where you can do it by yourself. F inverse of x equal. All right, so remember, the inverse undoes what the function did, right? Okay? So if this function multiplied by 3 and then subtract 8, go backwards. You're going to add 8 and then what? Divide by 3. Divide by 3. So the inverse function does this. You're going to take your value x. You're then going to add 8 and then take the whole thing, divide by 3. There's your inverse. And you can check it, by the way. I'll do another one just to show you what it is, but you can check it. Remember we said that in this t-table, the inverse takes takes -8, brings it back to what? 0. So if -8 is now my x value, what's -8 plus 8? 0. 0 divided by 3 is 0. -2. What's -2 plus 8? 6 divided by 3? 2. -11. What's the -11 plus 8? -3. Who? -3. David, you need a calculator, okay? -3. What's -3 divided by 3? -1. That's very simple. All right, now let's try this one. Suppose you're told g of x is 2x plus 1 divided by, 2x plus 1. Now, how do you read this right here? G inverse. So first of all, in order to talk about the inverse, g of x better be 1-to-1. Is it a 1-to-1 function? Yes, because all linear functions are 1-to-1, meaning that for each y coordinate, there's only what? One x coordinate, except which linear function? Horizontal line. What is it? You can take x, you can do what?
X plus 1 over 2.
No, David, do the opposite. -1, and then do what? Divide by 2. Because what did f do? I mean, g, what did g do? G, the operations were multiplication and addition. The inverse, we do the opposite. So instead of addition, it would be what? Subtraction. Instead of multiplication, it would be division. That's all you do. So I'm going to ask you this. Yes. Or I'm going to ask you this. If 5, -2 is on the graph of h of x, if 5, -2 is on the graph of h of x, and use what we just talked about. See that t-table, all that information we did? Then blank is on the graph of h inverse of x. -5. Remember, the inverse undoes what the original did. So the original took 5 and got what? -2. The inverse does the opposite. It takes -2 and gives you what back? 5. So -5. It kind of makes sense because look right here. If x was -8, what was my y value? If x was -2, what was my y value? If x was -11, what was my y value? So in this graph, 0, -8 is on this graph. On this one, on the inverse, what's on it? It's just the interchange of the coordinates. So basically, all you do is the interchange of the coordinates. Okay. All right. Now let me give you a couple of worksheets, and then we're gonna do some more with this tomorrow.